Good afternoon, everybody. Welcome to another fun-filled afternoon of Chem 170 with your host, me, Dr. White. And like I said, during the first break, I'll upload test number 2 because when we're done today, hopefully I'll remember. Yeah, I already have it posted on my mirror in my bathroom to remind me. I will send out the email with the password for test number 2. And that way you could take it and have it in by tomorrow morning. Uh, Test number 2 I've already discussed. And let me get this because I'll need it for my whiteboard tablet. And let's get back to work. All right, yesterday, and remember what I'm going through now will be on test 3, not test 2, but next week is test 2. So things are happening rapidly in this class, and that happens in the summer. All right. And yesterday, everybody see Ester reactions on the screen? Help me out. Thank you, thumbs up, people. What a day. Anyways, yesterday I talked about and started talking about if you take an ester and react it with acid and water, you get back the carboxylic acid and the alcohol you would have used to make that ester. And where do you find acid and water? In your stomach. And we'll be coming back to this acid hydrolysis of esters reaction later on, because this is how your stomach breaks down fats and oils, which I'll be teaching you about. So let's do a couple. Remember, the reaction is ester, acid and water, water and acid. Doesn't matter which order these are placed. You get back the carboxylic acid plus the alcohol you would have used to make that ester.
Dr. White, we can't see what you're writing.
Oh, no. Today isn't Friday the 13th, is it? Usually that's a lucky day for me. Thank you for letting me know. Now can you see it?
Yep, thank you.
You're welcome. No, thank you. And let me finish the structure. And what I was saying is if you take an ester, react it with acid and water or water and acid, you'll get back the carboxylic acid plus the alcohol you would have gotten used to make that. And it's your turn. What would be the product or products of the following reaction? 3 points each. Well, half of you are done. All right, I think everybody's done. So let's do this. And how do you do this? You identify what functional group is in there and look for what's different. Carbonyl, oxygen, carbons on the oxygen, I'll call R prime. And on this carbonyl carbon, carbon double bond oxygen, I'll call that R. And when you react that with acid and water, or water and acid, you'll get back the carboxylic acid plus the alcohol you would have used to make that. So if we look here, this is R prime, which tells us I have two carbons, then I have this carbonyl hydroxyl group. So I get this carboxylic acid, and then my alcohol is three carbons. Notice the end carbon is bonded to the oxygen here. Therefore, my hydroxyl group will be on the same carbon, the end carbon of three carbons. And I know there's four bonds to carbon, so I can put in my hydrogens, and that's how you do it. Oh, let's have some more fun. On test number 3, there'll be 3 or 4 synthesis problems. And the question is, what do you react with acid and water to make those two compounds? Your turn. Well, I see a couple of you are done, and I'll give you a little more time to finish. Those who are done, please be patient. And it looks like everybody's done, so it's time for Dr. White to get to work. And how do you do this type of problem? You look at what's different. Ooh, a benzene ring, but that I'm just going to call R because I have a carboxylic acid. And carbon, hydroxyl group on a carbon, alcohol. And what reacts with acid and water to make a carboxylic acid and alcohol? And the answer is an ester. And what's R? My benzene ring. What's R prime? Methyl. So if I use this as my ester, which it is, R to my carbonyl, carbon double bond to oxygen, then oxygen again to the same carbon. My R group is methyl. And that's how you would do it. And that's how you do acid hydrolysis of an ester. Now, another key reaction of esters is called saponification of the ester, of an ester. And remember, I will never ask you on a test or a final a name of a reaction. And this is a key organic reaction. Well, you say that about everything. Well, this has been, because this is a way for many eons people made soap. And the type of soap I'm talking about is the bar soap, which I still use because I also, for my hands, I use liquid, but in the shower or bathtub, in the shower mainly, I'm a bar soap person. And later in the semester, I will be talking about soap. And also, in case you don't know, when you use soap like to wash your hands, you're doing organic chemistry because organic chemistry is all around us. It is. Well, let's look at this reaction, saponification of an ester. And really what it is base reaction with an ester. And here, what do we have? Whoa. We have a ester. We're reacting with water. And for this class, I'll use sodium hydroxide as the base. And sometimes you'll see me write it this way. And what you get is not the carboxylic acid you would have used to make that ester. You get the carboxylate anion of the carboxylic acid you would have used to make that ester, plus you get the alcohol that you would have used to make that ester. Why do you get the carboxylate anion? Well, let's take a look at this reaction. What I'm going to write now, you don't have to ever know, but this will give you understanding of what's happening. Now, when you have hydrolysis of an ester, you'll get back the carboxylic acid and the alcohol you would have used to make that ester. However, this can't be isolated. That's why it's in brackets, because as soon as you make this, remember the reaction I taught you earlier, carboxylic acid plus base in a water or other solvent will immediately be an acid-base reaction, and this proton is removed to give the carboxylate anion. And therefore, whenever there's base present and you make a carboxylic acid, this reaction will happen immediately, even quicker than immediately, in a nanosecond, a billionth of a second. It's probably the fastest of all reactions. We call that diffusion control, because as soon as the sodium hydroxide hits the carboxylic acid, it reacts quicker than I can snap my fingers, even much quicker. And let me do this one. You know I'm going to share the fun. And the question is, what's the organic product or products for the following reaction? Because this is how we react things. And later on, this reaction was used for many eons to make soap. Our ancestors, and we still use. In fact, I worked for a company that sold the raw materials to other companies for them to make soap. We'll talk about that when we get into fats and oils. But anyways, what's different here? Ooh, carbonyl, oxygen, carbons here, carbons on the carbonyl, ester. I'm reacting it with base and water. Remember, sodium hydroxide is a base. I'll never ask that, but you should know. And what I get back is not the carboxylic acid, but the carboxylate anion of the carboxylic acid I would have used to make that ester, plus the alcohol I would have used to make that ester. If you put the carboxylic acid there, I'll mark it wrong, because in base, that will never exist. What's R? This. What's R prime? This. R, carbonyl, oxygen with a minus charge, sodium plus. You don't have to put the charges there, but I do. There's 4 bonds to carbon. What's R prime? Ethyl. And that's how you do it. For those who are writing it down, while you're doing that, I'm going to take some water. It's been a busy morning for Dr. White. And afternoon now too. All right, let me have you try one. And there you go. What would be the organic product or products? And on the test, I would do this, and that would let you know there are two products. Have fun. Am I nice or am I nice? Don't answer that. Give you a few more seconds to finish up. All right, let's do it. If we look up here, look for what's different, what's not carbon, what's not hydrogen, should get your attention like that. Also, what's not a carbon-carbon single bond. Ooh, oxygen's here and here. We got a carbonyl, carbon double bond to oxygen, with an oxygen on that same carbon. That oxygen has R group carbons, I'll call R prime. The carbonyl carbon has carbons, I'll call that R. And when I react that with sodium hydroxide and water, what do I get? The carboxylate anion of the carboxylic acid I would have used to make this ester. Why? Because you're in base. Next, I'll also get the alcohol I would have used to make that ester. What's R? Isopropyl. What's R prime? And propyl. And therefore, R group isopropyl, carbonyl, this carboxylate part of the carboxylate, there's 4 bonds to carbon, so I can put in the hydrogens. My R prime, the carbon with the oxygen here, is the carbon with the alcohol here. And therefore 3 carbons, and carbon will get it. And there you go. For those of you who are checking at home, I'll give you a few seconds to check. All right, let's try one more. Let's have some real fun. And the question would be, what would you start with and react with sodium hydroxide and water to make these two compounds? And that, in case you can't see, is Na+. Ooh, somebody I think is getting this. Some other people too. And let's get going, because I think everybody's done. I always try and give people time to finish. All right, what's different? What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? Ooh, carbonyl, oxygen, negative charge, sodium cation. For this reaction, I'll always use sodium hydroxide. Ooh, carbons, carboxylate anion. Then I got a benzene ring, but I've got an alcohol in there. I'm going to call this an alcohol. What's my R group? That. What's my R prime? The benzene ring. And what do you react with base, sodium hydroxide, and water to make those two compounds? An ester. And therefore, knowing this, I can say our group is this, carbonyl, oxygen, and my R group is a benzene ring. This is one way you could have drawn the benzene ring. Oh, it looks like a little smiley face, sort of. Oh, sort of. But anyways, that's called saponification of an ester. And in the old days, the settlers would take in a big pot. Oh, let me ask something. How many of you have ever heard of lye soap? Give me a thumbs up if you've heard of it. Oh, I guess not. Well, they used to call the soap made this way by saponification. You can still look and find it on the internet, lye soap. Let's see if Dr. White's lying to you. And if you notice, they show lye soap. And it's in Wikipedia. You know, everything in Wikipedia is true. No, but anything dealing with chemistry is. Let's take a quick look. Sodium hydroxide. And it comes from reacting that. I don't see it real quick. But anyways, well, they're talking about lye, not lye soap. And if we go to shopping, you can see all different ones that grandma's soap, which is that old. And that's lye soap. All right. Now let's talk about a really, and I mean really amazing reaction that Dr. White loves. And that's because it deals with Grignard. There's a mistake here for you, not for me. There should be a 2 in front right here. So let me rewrite this, and on a test, I would write it this way. Ester reacting with not 1, but two Grignard reagents. Remember, X can be chlorine, bromine, or iodide. And second step, you add acid and water. And what makes this amazing is keep your eye on the carbonyl carbon, what's attached to it, and you make not 1, but 2 carbon-carbon single bonds, something very rare, very special. This becomes an alcohol, and then this group here becomes the alcohol you would have used to make that ester. And the key thing is this first one right here. And this is a way of making some very complex molecules quickly with simple starting materials. Simple ester, simple Grignard, complex molecule. Now, when you do this, you try and keep R prime small so you can distill off and remove the alcohol and be left with the larger alcohol here, because this will have a larger boiling, higher boiling point than this. Oh, that's right. You do know about distillations. Let's have some fun with this reaction. Let me first of all show you something before we have fun. And sometimes I'll forget to put the 2 at my level. We don't, because everybody knows there's a 2 there, which is why I forgot it on the slide, because I didn't see anything wrong. But for your level, I did forget it. All right, what I'm going to do now, you don't have to write down, but Dr. White's going to have some serious fun. Plus, it'll help you understand how this all happens. Well, here we take the first Grignard and react it with the ester. This attacks here, opens up, then comes back here, and this gets kicked out. And what you get is this compound plus this compound. Now, this is a ketone. And you know about ketones, I hope so, for your sake, when you take test 2. And now we have a second Grignard reagent. And second step, hold on a second, let me clean this up. No, I should only have 1 there. Sorry about that. Second step, acid and water. And you've seen this reaction before, like for test number 2. This attacks that and makes an alcohol. Well, since you've attacked it twice, once, twice the carbonyl carbon, that's why we have 1, 2 R groups. Now this right here is a very strong base. And when I add acid and water, that's what you get. And this is not even a full mechanism. I sort of gave you a Cliff Notes version of it, but every reaction I teach you in this class, I can write the mechanism for. And as an organic chemist or chem major, when you take the 2 semester, you learn those mechanisms. And on the test, not in ours, you have questions about what's the mechanism and all that. In fact, a very complex reaction that I did use for my PhD thesis when I had the fensamide thesis, otherwise known as your orals, not a fun time in life. High stress because you're with 4 professors, you're a professor and 3 others, your advisor, and for the next couple hours, you present your thesis, you defend it, and they can ask you questions about anything. And if you flunk, you don't get your PhD. Talk about pressure. Good news, I didn't flunk. There's only pass or fail grade. All right. Let's have some fun with this. And let's look what's different. Ooh, carbonyl, oxygen on it, carbons, and ester.
We can't see the whiteboard.
Oh, Dr. White's. See what happens when my day is upended? It affects my brain. All right, now can you see it?
Yeah.
All right. Did I write it on the wrong thing? I bet I did. No, maybe, well, yes, I did. All right. I was writing it on the slide. I saw a white surface, not related to me. Oh, that was an awful joke. Let's do this again. Can you see it?
Yes.
Thank you. Keep an eye on me today. And I forgot to two there. Oops, I caught that error. And the question is, what two products do you get? And on the test, I'll give you a plus sign to let you know there are two things. And what do we see here? Carbonyl, oxygen, carbons on the oxygen, carbons on the carbonyl. I have an ester. I'm reacting with two molecules of the same Grignard. And remember, X can be chlorine, bromine, or iodine. And then, second step, we add acid and water. And what do you get? You get, keep your eye on the carbonyl carbon, because that's where the fun is. This becomes an alcohol, and you do that very special thing. You make not one, but two carbon-carbon single bonds to that carbon right here. And then you get a second molecule. This group forms this alcohol. So let's take a look. This is my R. This is my R prime. And this is my R triple prime. So I better give myself some more room here. Keep my eye on the carbonyl carbon. R is two carbons. It will have a hydroxyl group. What's my R triple prime? The carbon with the Grignard will be bonded to this carbon. Not one, but two of them. And then we'll get R prime as the alcohol. And don't forget, there's 4 bonds to carbon. And there you go. If you notice, I made a very complex alcohol that I could use for other things that we'll learn in general reactions already. I could make a very complex ester with this. Like if I worked in a perfume company, which I don't, but if I did, I could. And that's the reaction. And actually, I'll move it down here, give you more room to write, me too. And when you do that, you get two things. And that's what this plus shows like. Have fun. Your turn. And for those already done, please be patient. All right, let's do this. If we look at this reaction, the first thing I have to ask myself, you don't have to, but it helps a lot, is what's different? What's not a carbon-carbon single bond, carbon or hydrogen? And, ooh, carbonyl, it's the same carbon, oxygen. There are carbons on both of these, ester. And I have two of what? Carbon, magnesium halide, a Grignard. Number X can be chlorine, bromine, or in this case, iodine. And second step, acid and water. And what you get, keep your eye on the carbonyl carbon, is you make not one, but two carbon-carbon single bonds to that. And this opens up to an alcohol. And then this part gives you the second alcohol. Then let me sort of give myself some room here. And so this is R prime. And here we have our triple prime. So I'm going to stick with the carbonyl carbon because that's where the fun is. And this tells me I have R, which is methyl. I'll have my hydroxyl group. And then my, not one, but two R triple prime. And guess what? I'm not done because you have a second alcohol. And what's R prime? Ethyl. And that's how you do it. And if you look at the product, this we keep small so you can distill off. The main one is this one where you make not the one, but the two carbon-carbon single bonds with a very small ester and a small Grignard. We've made a very complex alcohol. And that's fun. And also it's important. You need those, which those are used to make many things in our daily life. Now, good news, at least as of today, the Supreme Court of the United States is still outlawed cruel and unusual punishment to students. So that means on that Grignard reaction, I will never, ever on a test or a final put the synthesis. Here's what you make, what do you start with? That's not fair. And Dr. White always tries to be fair. And speaking about fair, let's take a break now. Come back in about 6 or 7 minutes, maybe a minute or two after that, because I've got to fix the mistake I made, bad Dr. White, by not uploading test number 2 for you. So let's take a break. I'll see you in about 6 or 7 minutes, maybe even 8. I'll blow the whistle when it's time to start again. I'll see you in a couple minutes because I've got to go upload the test.
Right.
I'm back. Oh, let's have fun. Everybody back? It's a lot of work putting in a test in Blackboard or D2L. All right, thumbs up, people. Do you see D2L? And let me log into Chem 170 on. Thank you. And just to show you, if we go to the assignment area, test number 2, but this is my view. So here's what I'm going to do. View it as a student. And now you're viewing it as a student. And look what's there now. Test number 2. And I gave you till 11 o'clock tomorrow to get it done. Because tomorrow morning, God willing, and I hope he is, I'll be doing my lawn, having fun with my lawn while it's still nice out before it gets too late. I'll probably be done way before that. I'm shooting to be done by 8:30, 8:45. I start at 7:30 because I don't have to teach. And that's that. Thumbs up, people. Can everybody see that Chem 170 test 2 is now in? Thank you. Whoever let me know, thank you very much. Bad Dr. White. Well, life happens. The last day or so, I've had a lot on my plate. Ugh. But anyways, I'm having fun now with organic chemistry. Oh, let me do one thing first. We'll log off of this. First of all, switch back. And log out. All right. The next thing I'm going to show you, don't write down what I'm going to do on the whiteboard. Again, the next thing I'm going to show you, don't write down on the whiteboard. I just wanted to teach you something. And what I'm going to write, you don't have to write down. Now, let's talk about a couple of molecules. And let me make sure I can get this out of the way. Does everybody see polyester on your screen? Thank you. All right. Now, turns out something I stayed on purpose away from, molecules can have more than one functional group in it. If you look at the common name, this is called Pterophithalic acid. You have a benzene ring, but over here you have a carboxylic acid, and here you have a carboxylic acid. And if we look at this molecule, which we've actually talked about, ethylene glycol, it has not one, but 2 hydroxyl groups. So think of this as 2 alcohols. But let's look at the reaction of this. In real life, there might be an acid catalyst here, or this is slightly different. So you don't need a catalyst, but we won't cover that in this class, at least now. So what does this mean? Well, let's look at the whiteboard. Again, don't copy this down. Pterophithalic acid plus, I'll write it this way, ethylene glycol. And if we needed, we could add an acid catalyst. And what do you get? Well, if we look at here, let's just look at that one. I've got a carboxylic acid. All this stuff I can call R. And here I have two alcohols, but let's just think about R prime acid. And look at this alcohol and the rest of this I'll call R prime. And when you do this, carboxylic acid, alcohol, what do you get? You get an ester. Oops. Oops. You get an ester. Well, if I do that, I'll have my R group. Which includes this. And then I'll make my ester. And my R prime is CH2, CH2OH. Now, if you look at this new molecule right here, it has a carboxylic acid and an alcohol in there. And it can react with either more terephthalic acid or more ethylene glycol. Let's react it with more terephthalic acid. Remember, don't write this down. Here I have a carboxylic acid. Here I have an alcohol. All of this is my R prime. All of this is my R. And what I'll get is the following. And I now have this. And over here, I still have carboxylic acids that can react with more ethylene oxide. And like the Energizer Bunny, I could keep adding on both sides, on and on and on. I think you're all familiar with that commercial. And what do you get? Well, you're going to see a repeating unit. And that repeating unit would look like this. And N here can be large, like about 1 million or more. That's pretty large. And remember, when you have that N in this bracket, this is repeated over and over again, like the boxcars in a long freight train. And the name of this new molecule is called poly. Poly means many, from ethylene glycol, ethylene for the alcohol, R prime. Remember, ATE, you drop the IC in acid, name of the carboxylic acid, and you put ATE, the IU back way, the other way it's OATE, and you get polyterephthalic acid. And let me just do something and move this out of the way. So you make this material polyterephthalic acid. Did I tell you two things? One, we're at that point in the semester and have been for a while. You should constantly ask the question, why am I learning this stuff? And the obvious answer is you want to get a good grade so you can get into school or a program. But why are they making you learn this stuff? Good question. And the other thing is, did I tell you how lazy organic chemists are? We are lazy. And if you look at that molecule we have on here, that's polyethylene terephthalate, wow, that's a lot of work. Hold on, I've got to get something to drink. Polyethylene terephthalate, that's hurting my jaw. That's a lot. I'm a lazy organic. I don't want to call it that. So what can I do? Well, I can look at the name here and say, get a black pen, P, polyethylene, E, terephthalate. Instead of saying, oh, that long word, polyethylene terephthalate, I can just call this polymer that I just made, PET. And that's the material that's making up the plastic in this bottle. These water bottles, 2-liter and even smaller pop bottles, are made of PET. This is a polyester. Why are you learning about this stuff? Well, I don't know about you, but I like these much better than if it was glass. It's lighter, it's recyclable, so is glass, and it's cheaper to make for the companies that put things in here. By the way, I recycle these and refill them for a while until I finally get rid of them and use new bottles. I buy these in bulk from Costco, even though they don't give me any money for saying that. But think about it. Why are you learning this stuff? Why learn about a carboxylic acid and an alcohol make an ester? Well, because it makes this. And also this. Some of these are called polycarbonate lenses, and these are actually polyester. My lenses of my, where'd it go? Oh, that's where you want bad humor Thursday. So next time we're doing something, always ask the question, why am I learning this? And one of these things is plastic bottles. We use them all the time in our daily life, and they're made from Fischer esterification. Oh no, if you look at the bottom here, if I go like this, we're on slide 31 of 31. And you know what that means? We're done with this chapter. Listen carefully. On Monday, I will go through the problem set for the carboxylic acid and ester problem set. Make sure between now and then, after you do test number 2, you work on that like over the weekend. And the way it goes, I believe a week from today will be test number 3. And next Tuesday, I'll give my world famous review for the next test. And on next Wednesday, we'll go through the problem set of the chapter. I'm going to start now because it's new chapter and functional group time. Now, I have to warn you, if it looks like Dr. White's having way too much fun, I am, because this new chapter, for many years, I worked for companies that, or one company in particular, that made these functional groups I'll talk about. And I was responsible for all the research and development in these functional groups in all North America. It was fun. And also it was challenging at times. And we're going to get into stuff you never thought about. I'm going to give you the inside scoop about things you never knew about, but because I worked in these areas, I do. What's this new chapter? Well, I better open it up. And the new chapter is a combination of chapters, if you're reading the book, 11 and 13. Amines, amides, and heterocyclic compounds. Does everybody see that on your screen? Because I've been pretty bad today. Thank you, Joanna. All right. Now, what's an amine? Well, it's an organic derivative of ammonia. Ooh, what's ammonia? I'll never ask on a test, but ammonia is NH3. This is ammonia. And what an amine is, and I've worked on amines, I've created new amines, so Dr. White's happy now, is derived from ammonia, where one or more of the hydrogen atoms on ammonia are replaced with either an alkyl group, R, a cycloalkyl group, R, that's a ring, or an aryl group, R, that's a benzene ring. Now, here's something important. Nitrogen has 5 valence electrons. The Lewis structure, and this I'll never have on a test, but it's important to know something. And therefore, unlike carbon, which has 4 valence electrons, all atoms want to get an octet. So if I have 5 here, how many more to 5? 3. If I have 4 here, how many to 5? How many to 8? 3. Sorry about that. I have 4 here. How many to 8? And you know 4 bonds to carbon. Well, it turns out most nitrogen compounds have, besides the nitrogen, have 3 covalent bonds to it. Now, nitrogen has this lone pair of non-bonding electrons. And in special cases, nitrogen can have 4 bonds to it. So this gets a little confusing. For amines, you always have 3 bonds to nitrogen, unlike carbon, which is 4. Amines, 3 bonds. But in other things I'll teach you, sometimes nitrogen can have 4 bonds. So it can either have, amines are always 3 or sometimes 4. It's a little confusing, but pay attention, you'll get it. Now, I'm turning the switch off for this slide, but since I'll use this terminology, you should be familiar with it. There are 3 types of amines. Primary amine, when there's 1 R group on the nitrogen. And notice 1 R group plus 2 hydrogens, 3 bonds to nitrogen. And this is called a primary amine, also abbreviated this way. Secondary amines, you have 2 R groups on the nitrogen. And remember, there's 3 bonds to nitrogen, so that's why there's only 1 hydrogen, not 2, that's carbon. And we sometimes will abbreviate it like this. Secondary amines, similar to alcohols. And finally, you can have a tertiary amine. And notice I have 3 bonds to nitrogen, and I don't have no hydrogens. And this is a tertiary amine. And again, I'll never ask this on a test. Now, I'm going to talk about something very dear and near to my heart, quaternary ammonium salts. And what is a quaternary ammonium salt? The non-bonding electrons, which I don't show here, can also bond. Now, since the non-bond, all the electrons on one of these bonds comes from nitrogen, it will have a plus charge. And all molecules have a net 0 charge, so you need an anion. For this class, I'll stick to this, the halogens. There are many others that I know about, but I'm not going to talk about them because in your daily life, these are the main ones you'll see, where X can be chlorine, bromine, or iodine. And I should tell you that since I've worked in this area, quaternary ammonium salts, I have about 9 US patents in this area, and I'm a world authority on quaternary ammonium salts. Dr. White's going to try and be a good Dr. White. What do you mean? Because if you work in quaternary ammonium salts, and I have for many years, we don't call it that. We're lazy organic chemists, and we just call them quats, short from quaternary ammonium salt, quats. I will be good, and I won't talk about them here in terms of using the slang, and this will be the last time. Quats is quaternary ammonium salt. Now, good news. I'm not going to go through the IUPAC nomenclature of amines. Yes, I do know them, but everybody uses common names. And these common names are list the alkyl group or the cycloalkyl or the aryl. By the way, benzene on amine, which I won't ever put on, is called the phenyl group when it's a substituent. I should tell you that. But I won't ask you this on a test. I think I spelled substituent right. If not, you correct it. It's called the phenyl group, and all chemists, Matt, pronounce it that way. So when you have this on the chain or ring, and this is a substituent, that's called the phenyl group. But anyways, for amines, you just name the alkyl groups attached to it. And I don't have it on the slide, I better put it. At the end, add the word amine. So let's take a look at a molecule. If we look at what I just drew, and thumbs up, people, do you see CH3N2H2 on your screen? Thank you. Keep an eye on me today. I've already made a couple of mistakes. And what's different? And again, look for what's not carbon or hydrogen, carbon single bond. Ooh, a nitrogen with one R group on it. This is a primary amine, and this would be called methylamine. And let me have you try one. What would be the common name for that molecule? Your turn. And when you're done, give me a thumbs up. Remember, name each alkyl group, and at the end, add the word amine. All right, I think everybody's done. What's different? Ooh, nitrogen. That should get your attention immediately. And what's on there? A methyl group and an ethyl group. Now, since this is a common name, it doesn't matter which you put first. You could just as easily put ethyl first, but I'll put methyl. Either way is correct. And it's an amine. Now, let me show you convention organic chemists use, and I use without even thinking. if we have this compound, this would be dimethyl, 2 methyl groups, amine. Now, when you have 2 or more of the same alkyl group attached to nitrogen, you can write it this way, which most organic chemists, including Dr. White, doesn't. We're lazy. So if they're 2 of the same thing, we use bracket OCH3, 2 NH. Doesn't matter which side you put the hydrogen on, that as long as it's not on this side. And this is the preferred way of drawing this compound, and you should be familiar with it. And that also plays a role in nomenclature. And that's how you, that's a molecule I'd like you to try. What's the common name, not IUPAC, for the following? While you're doing that, I've got to look up something that I always misspell. Always. Which is why I always have to look it up. Oh, I spelled it wrong again. Yep. Never fails. This is one of the rare words in all of organic chemistry I always misspell. All right, let's take a look at this. Thank you for waiting while I was checking to make sure what's the right way to spell something important. And here, what's this? Ooh, nitrogen. And notice I have 2 methyls and 1 N-propyl. And you could say this is dimethyl N, which is small case, propyl, amine. And that's how you name primary, secondary, tertiary amines. I'll never ask you, but this is a tertiary amine. And you could have also put N-propyl dimethylamine. Either one would be correct. Now, I don't think I have a slide for it. Let's find out if I do or not. I don't. Bad, Dr. White. So I better just instant slide. Now, a molecule that's very important, and I'll talk more about it later in the chapter, is when you have a benzene with an amine group on it. And this is not called benzene amine. This has a common name that IUPAC made the IUPAC name. And this is called aniline. And aniline, oh, I should tell you, amines are pretty stinky. Not as bad as thiols, but almost. And aniline and some other amines smell like dead fish you've kept in your backyard for a week or two in a Ziploc bag in the middle of summer. Awful. But anyways, aniline is an important product or compound. I'll teach you later on, but I might as well tell you, I've got black on. But if you're wearing anything that has colors on it, how do they dye cloth? they use a dye that's made from aniline, the molecule I just showed you. Yeah, organic chemistry is all around you, even in your clothes. You can't see it. Well, I've got black sweats on. Oh, here. This is a microfiber towel I get at Walmart. Hold on. Now you can see it. Oh, my camera doesn't like that. Here it's better. And these are real cheap and they're good for cleaning glasses, real good. You know how you get those things from your optometrist? These are just as good or better, and you get 5 for $1 or $2 at Walmart. I'm sure other stores handle it. Sometimes they're blue, they're yellow, they're white, and they're good for a long time. But anyways, that yellow color you just saw was a dye made from aniline and other things. I'll teach you later in this chapter. Now, I'm going to turn the switch off just for this next slide, but I'd like you to learn about, just be exposed to the IUPAC name for amines. And how do we do that? It's similar to alcohols, except instead of changing the E to a OL, you change the E at the name of an alkane for the longest chain to the letters AM, INE, amine. Now, for secondary and tertiary amines, capital M, N is used for the substituents on the nitrogen. This is something new. We haven't experienced this before. And by the way, amines and where additional functional groups are present, the amine group is treated as a substituent and called an amino group. And later, when we get into proteins, I'll come back to this phrase. Or maybe I'll show you that right now in a second. So let's look at something why you use common names. Can everybody see the whiteboard? I got to check today because I've been messing up. Thank you. Now, what's the longest chain this nitrogen is on? 1, 2, 3, 4, 5. That's pentane. Drop the E and add the letters AMINE, pentanamine, which is not coming out of my mouth nicely because I rarely use IUPAC names, even though I work in this area now for decades. And what carbon is the amine group on? Carbon 1, the lowest one. So that would be like alcohols 1, pentanamine. But notice on here, we have 2 methyl groups, and they're not on the chain. Again, switches off right now. So how do you name them? They're both on the nitrogen, and we use capital N, since there are 2 of them. I need 2 of them, NN, dimethyl 1 pentanamine. And it's a lot easier saying dimethyl pentyl. By the way, I didn't teach this, but N-pentyl would be for that alkyl group, dimethyl N-pentylamine. But now you understand why I'm always careful for N-propyl and butyl is lowercase, because capital N means you have this, whatever's in front after the capital N on a nitrogen in an amine. And that's how you do it. Now, one of the things I always forget to do, and I did, and that is, how do you name quaternary ammonium salts? And here we have a quaternary ammonium salt. And how do you name these? Well, it's simple, like common names. 1 and make sure you write this down or come back to the video and see that. Name each R group here as an alkyl group in the front of the name. 2, for quaternary ammonium salt, you name each R group at the front, and then at the end, you add the term ammonium halide. Now, what do I mean by halide? Excuse me. Mother trained me well. When it's Cl minus, we call that chloride. When it's Br minus, that's bromide. And when it's I minus, that's what X is, can be chlorine, bromine, or iodide. And then it would be Cl minus, Br minus, I minus. This is called iodide. And these are the halides. Now, there are other ions that I've worked with, like borate and acetate, but we're not going to cover that. And these are quaternary ammonium salts. And I've been good. I haven't used slang. I keep on calling them, for you people, quaternary ammonium salts. Now we're getting into the good stuff where you can ask the question, or really I will, and tell you, why am I learning about this stuff? Well, quaternary ammonium salts can be used as fabric softeners. And I have a number of patents where they are used in fabric softeners. When I worked at AXO, our largest customers were Procter & Gamble, which make Downy, and Unilever. It used to be called Unilever Brothers, but now it's Unilever, and that's called Snuggle. And they make fabric softeners, which make your fabric, when you put it in either a washing machine or dryer, soft, and also gets rid of the static, like in the winter when it all bunches together. And that's why I use a fabric softener. Now, hold on one second. I'll be right back because I'm going to have a show and tell for you. Good news, it's show and tell time from Dr. White. Now, when I was in third, fourth, fifth, sixth, and seventh, especially eighth grade, and we had English class where it was show and tell, the teachers were frightened of what I would bring in, because I'd always bring in something for show and tell that you have to give a report on and talk about in English class. So they're teaching you how to write reports, that the English teacher there had no idea, because they weren't science majors. Already I knew I was going to be a chemist. What I was talking about, they didn't like any of that. But let's do a fun show and tell. Now, I have to tell you something personal. In my family, and it's hereditary, we have major dental problems. My mother had it, my sisters have it, and unfortunately, I inherited it from my mother, who inherited it from her grandfather and grandma. I think it was my grandfather had real bad problems. Interesting, my father didn't have any bad dental, but I wound up with the wrong side of the family tree. And a number of years ago, I started having problem with my gums. They hurt, and they were having gum problems. And the dentist at the time, really great guy, since passed away, said, you need a special prescription mouthwash. It was like a pint bottle or a little bigger that you have to have a prescription, which he gave me. And it was $70 a bottle back then. And even worse, it would turn your teeth slightly brown, but you'd brush them the next morning after you use it. And it was, but it helped. Well, anyways, he retired and I went to in between dentists for a while before I went, and prescription ran out. What do I do? And my gums were starting to hurt. That if I did this, I'd be in serious pain by just doing this. Well, I'm an organic chemist, so I went to my local big box store, which in this case happened to be Walmart, and there's a big wall of over-the-counter mouthwashes. And there are two main types, Scope and also Listerine type. Now, the Listerine uses a phenolic compound, a benzene ring with a hydroxyl group and some other stuff on it to kill bacteria in there, which isn't that good for my mouth. Other people's it might be. I tried it, and guess what? Oh no, I'm still hurting. I got to find a dentist. And I said, wait a second, let me go back. And I looked at the other type, which was Scope. And Walmart sells their own bottle, which is quite lower priced than Scope. And I looked at the label and I see this. And then I see cetylpyridinium chloride. You probably can't see it, but it's right there. And I know there's another way on trade names on labels. Sometimes they use that way. And that's a quaternary ammonium salt. And quaternary ammonium salts are antimicrobial, antibacterial compounds. And I bought some. I still do. I got another bottle in my bathroom unopened. And guess what? No problems. It killed all the germs in my gums that was causing problems. And now religiously, and I mean religiously, every morning I use this. And that's why I've got backup bottle because I don't ever want to run out. And every once in a while, I'll go to Walmart, and that's the cheapest price around, and get their brand name equivalent to compared to Scope Original Mint. And I buy about 3 or 4 bottles, put them in my utility room till I need them. And that's a quaternary ammonium salt. Quaternary ammonium salts have been used in disinfecting operating rooms. And if you looked at the Pfizer vaccine, besides the, what do they call it, RNA they put in there, there's also 2 quaternary ammonium salts. I wonder if they also are good for attacking COVID-19. Now, let's talk about, do I have time? I do. Let's talk about fabric softeners because that's an area I worked in quite handily. Let me just move my mouthwash bottle out of the way here. How many of you have ever had a towel you've had for a while, like a bathroom towel you use for after you take your bath or shower, and even dish towels, and you go to wipe, and it's not absorbing the water as good as it could? Well, it turns out, I'll teach you more about this in when we get into carbohydrates and talk about cotton and how that and paper towels, work. Well, guess what? When you use a fabric softener, it blocks some of the sites on a regular towel from absorbing the water. And that's in the industry, which I worked in, is called the re-wet. Your re-wet gets bad, doesn't absorb water. You know how you make them good again? You wash them once or twice and don't use a fabric softener. And that way, your towels, you've taken off some of the quaternary ammonium salt that was blocking the towels from working well. And guess what? It will work good again. Now, 2 more stories. Yeah, I've got time. Hang in there. One is, having worked with Procter and Gamble, and another day I'll tell a 3rd story, but not today. I don't want to overdose you on stories. But having worked for Procter and Gamble, And after I've gone down to our research center, I take the guys out to lunch or dinner and a few drinks, and then we start swapping stories about our companies. And one interesting story I learned about from Procter and Gamble, P&G. They were the first company to come out with the dryer fabric softener. Before that, you put a liquid into your washing machine at the rinse cycle. By the way, the dryer sheets work much better than putting the fabric softener in your washing machine. And that's what I use. I do use a fabric softener. Well, anyways, the story I heard was, and I know it's pretty true because I've heard it more than once, that when you have a large international company like P&G, Procter and Gamble, when they're coming out with a new product, their marketing people have already done a lot of research and told upper management, here's what our first year sales should be, or first 2 quarters. And usually they're pretty close, not exact, but they're going to be somewhat close. Well, they came out with the Downy sheet dryer fabric softener, and their sales were half of what they predicted. That's awful. Half. And upper management wasn't happy. Why aren't we making all the money we should be? We're only selling half of what we should be selling. Well, big companies do market research. And one of the things I learned from both Procter and Gamble and Unilever is the profound respect they have for the housewife, the American housewife and other countries too, because she is a smart person. Surprise, surprise. And what they found in their research was the original Downy sheets you put in the dryer, the housewife figured out, guess what? If I save it, I can use it a second time for another load, and it still works good. And what did they do? They cut the amount of quaternary ammonium salt that's on the dryer sheets in half. And guess what? Their sales jumped up double to what they expected. It was pretty close. And that's just, how should I say that? Working in a big company who's trying to maximize profits. Now, the other story, and then we'll take a break, is when I worked for one company, Axo, another company that was part of Unilever but didn't make quaternary ammonium salts, I had helped them out with a problem that they were having that was causing my company problems. So I got to be known throughout that company, that division. Well, they needed someone when they were moving all their operation, research, and production to Chicago area by White Sox Park to be a laboratory manager. Well, I was working at Axon, making a very nice salary, but they wanted me. I said, no, I'm working on a place I'm having fun. And then they made me an offer I couldn't refuse. They doubled my salary. I said, bye, Axo. I went there. Well, one time in England, Unilever is an English company mainly, Dutch English, but mainly Dutch English. I was at a senior R&D, research and development managers meeting in England, and chemists know how to party hard. And that night, each night of the meeting, we had a where people presented things, what's going on in the company. We'd all get together, have a nice fancy meal, then go to a local pub, and the company would pay for us to get smashed. Well, anyways, the senior vice president for all Unilever was there. One of the colleagues I knew said, go over and ask him about Snuggle. And the Snuggle Bear, I said, what are you setting me up for? He said, go ahead, ask him. He won't get mad at you. So I go over there and introduce myself to him because he didn't know who I was. Unilever is huge. And he said, he sort of knew, I think he did maybe because I'd already made some major changes that helped the company. But anyways, I said, can you tell me the story behind the Snuggle Bear? And he smiled and said, sure, let's get another drink. And when they came out with Snuggle, you know, the little bear on the label or the box, inside Unilever, I was working for it then, it was years earlier, they had a competition throughout all of Unilever. They needed a mascot for the new fabric softener they were going to come out with. But one day he was going to go to work, and a small 3 or 4 year old son was going to say goodbye to his daddy. And he was holding this old raggedy teddy bear. And the father looked at him and said, "That's what we do. We can use that." He said, "Can I have your teddy bear?" And the son said, "No." Again, the father's telling the story. And he said, "It took me a couple of days, but I convinced my son I'm just borrowing it. I'm not going to take it away for good." And I also bribed them real good. I took it down to the people who were the competition, held it up and said, "This is our new mascot." And they used it. And he made a lot of money off that by winning the competition. Good money. Is there bad money? But anyways, he made a lot. And he brought the teddy bear back to his son. Good news. And that's the story behind Snuggle and the teddy bear. And if I look at the time, it's time to take a 5-minute break, come back at 2:55, and we'll continue. Take a break. I can use one. I'm back, as if you don't know already. All right. I was just checking my cell phone to see if I heard anything from my dealership about my flat tire, and not yet, but they're good on that. All right. Let's continue on with amines. Now, this is a quaternary ammonium salt, and there's one quaternary ammonium salt I'd like you to see, because this is something near and dear to my heart. It paid my rent, well, for a while it did, then helped me buy a home, paid my mortgage, paid for a couple of cars, and that's the following quaternary ammonium salt. Now, this is called the tallow group, or sometimes tallow alkyl. And when we get into fats and oils, I'll talk more about the actual structure. But I can tell you it has from a mixture of 16 and 18 carbons with and without a double bond. And there are two of them on a nitrogen, plus on this nitrogen, I have two methyl groups. And this is a quaternary ammonium salt. And the anion most common is chlorine or chloride. And this is called ditallow dimethyl ditallow dimethyl ammonium chloride. And up to about 10 years ago, this was the only molecule used as fabric softener. Now, about 10 years ago, a company found a way of getting a cheaper R sub T group, and now that's used. It's similar to this, but cheaper, and I won't talk about it now. That's called the Ester quaternary ammonium salt. But anyways, for many, many years, and still about 30 to 40% of fabric softeners, usually off name, not the brand name, are this molecule. And that's something very near and dear to my heart, because the company I work for, Axo, and that time was called Axochemy, now it's called AxoNobel, but that division they just sold off 2 years ago, and it's now called Durion, would make about 60 to 70 million pounds a year of this compound. If you're only putting 5% and 4 to 5% in fabric softener, that's a lot of fabric softener, and that's where this was almost exclusively used for. Now, I'll draw it this way. This molecule and switches off for that. This is group, a CH2 with a benzene ring, is called the benzyl group, which I'll never ask you to learn. And these are called benzo quaternary ammonium salts, where R can be anywhere from 10 to 18 carbons, with or without a double bond. And these are probably the best antimicrobial compounds. And these type of, they're called nicknamed benzyl quats. I said I wouldn't use quad anymore, but anyways, benzyl quaternary ammonium salts are mainly used for disinfecting things like hospital rooms, surgery, or what do they call them? Surgical rooms. And that works quite well. There are other compounds too, but that's quaternary ammonium salt. All right, switches off. Properties of amines. The smaller ones have a very strong ammonia odor, and most of them are liquids or most are solids at room temperature because of hydrogen bonding. If I have a nitrogen just like in water, and a hydrogen. And I blew that. I have another nitrogen and a hydrogen or more. You can have hydrogen bonding. And that helps change the melting point and boiling point to be higher. Now, how do you make, uh-oh, my computer just burped on me. Sorry about that delay, but that happens because I got so many things running on this computer. So everybody see on your screen now, synthesis of amines. Thank you. All right. Now, how do you make amines? Well, you react ammonia or an amine with an alkyl halide. Let's look at each one of these individually. By the way, this should be NH3. This should be subscript like that. And let's look at this one, reaction one. And I'll draw it on my whiteboard because we're going to practice it. If you take ammonia and react it with an alkyl halide, X here is chlorine, bromine, or iodine. Hopefully you're not having nightmares hearing me say that, but you say it enough in organic. And if you react the two together, one of the side products of this reaction is HX, an acid. And there's a reason you don't want acids around. That's why you put some base to neutralize that acid. And the base can be sodium bicarbonate, sodium carbonate, things like that, others too. And what you get is a primary amine. And what happens? The nitrogen attacks the carbon that has the halogen, and the nitrogen will be bound to the carbon in R that has the halogen. So let's do one. And it doesn't matter which you put first or second, like I just did. And the question is, what's the product or organic product or products are the following? When we look here, what's different, what's not carbon, what's not, ooh, halogen on a carbon, and that's an alkyl halide. Ooh, ammonia, that's different. And in the presence of base, you get a primary amine. Remember, in amines, there are 3 bonds. To nitrogen. And therefore, that's why we have 1 R group and 2 hydrogens. So if I look here, That's my R group. Do I break carbon-carbon single bonds? No. And that carbon with the halogen will now have NH2. And an amine group counts as one bond to carbon, so I can put in my hydrogens. And now I'm going to let you try one. Your turn. And don't forget after class, about 10 after 4 today, I will send out an email with the password. And during our break earlier, I checked to make sure the password, what I uploaded to D2L, I downloaded one, checked the password, and it worked. Whew. All right. I see one of you done. Give you a little more time. All right, let's take a look at this. What's different? What's not? Carbon, hydrogen. Ooh, halogen on a carbon, alkyl halide. Plus, oh, ammonia. And reacting with base, and what you get is a primary amine. What's my R group? N-propyl. This carbon with the halogen will be the carbon in R with the amino group, NH2, and it's called an amino group. So I have my R group. Notice there's 3 bonds to nitrogen. So 3 minus 1 means there's 2 hydrogens. And that's how you do it. Oh, let's have some more fun with this. Let's see if we're up to the challenge. And what would I react with ammonia in the presence of base to make that compound? It's called synthesis, and this is the fun part of organic. This one was challenging. Let's see if you're up to it. Uh-oh, Dr. White is challenging his students. I see one person done. Oh, you're not having 2. I haven't done this all day. And I think everybody's done. So, time to get to work. How do we do this? We look at our product and say, what's different? Ooh, nitrogen amine group on a ring, but that's this R. what do we react in the presence of base with ammonia, NH3, to make a primary amine? And the answer is Rx, where X can be chlorine, bromine, or iodine. Since I didn't show you anything here, which I could have, you could pick any one of these. So if I look at, this is my R group, therefore, I have a cyclohexane ring, and any carbon, doesn't matter which one, has a halogen. I haven't used bromine. You could have also put chlorine or iodine, and this will react with this to make that, and that's how you do it. Now, one of the things that happens is, this is called nucleophilic attack or substitution. The non-bonding pair of electrons are on nitrogen are attracted to the carbon with the halogen. It kicks it out, and that's how you form this bond. So these non-bonding electrons on nitrogen are quite important. Let's find out how important. Now, the second reaction, I apologize, the slide's way too busy, is this. You take a primary amine, react it with an alkyl halide, can be the same or different, in the presence of base, because you're generating HX and you don't want that. The non-bonding electrons do the same thing, kick this out, and you make a secondary amine. Let's take a look at that again. And thumbs up, people. Do you all see what I'm writing now on the whiteboard? Thank you. Now, one thing I should point out, what side R and R prime are in the hydrogen on the nitrogen doesn't matter, because molecules rotate, and I could have written it this way also in another variation. And there are a number of ways of doing it. You're in luck. Dr. White has at home a piece of paper signed by the Board of Regents of Michigan State University saying, I know these differences, my PhD degree. And let's do one. And the question is, what's the organic product or products are the following? And let's look at each one of these two molecules. What's different? Carbon, hydrogen. Remember, look for what's not carbon, what's not. Ooh, a nitrogen with hydrogen as carbon. This is a primary amine. Then here, carbon, carbon. Ooh, halogen on a carbon, alkyl halide. Remember, X can be chlorine, bromine, or iodide. And when you react that in the presence of a base, you get a secondary amine. So this is my R group. The carbon on the halogen, what has the halogen, is the carbon bonded to nitrogen in your amine. And we have our isopropyl group. And what we'll get, R group on nitrogen, hydrogen, and my isopropyl group. And that's the molecule you get. And now it's time for Dr. White to share the fun. I say fun enough, you might believe me. It is. And it's your turn to have some fun. I see one person done. Two. If you're not done, take your time. Almost everybody's done. All right, let's do it. Look for what's different, what's not carbon, what's not hydrogen. Ooh, a nitrogen with carbons on it, a primary amine. Carbon, carbon, carbon. Ooh, carbon with a halogen, an alkyl halide. Remember, X can be chlorine, bromine, or in this case, it's iodine. And in the presence of base, what do you get? You get a secondary amine. And now what's our ethyl? What's our prime? T-butyl. So I'll have my ethyl group, my T-butyl group, I know there's 3 bonds to nitrogen in an amine, therefore I have 2, so I need a hydrogen, and I'm done. That's how you do it. Oh, let's have one more fun. And what 2 things would you react to make this molecule? By the way, I'm going to give a little away. Say hello to my old friend here, diisopropylamine. I used that molecule in my research when I was getting my PhD, a lot of it. That was my old friend. I haven't thought about it for a while. Now you know I'm an organic chemist. It is my old friend. Say hello. I see a couple people done, but I will be patient. Hopefully those of you who are, please be patient too. All right, let's take a look at this. And what do we have? We have what's different? Nitrogen. And it's got carbons here and here. And what we have is a secondary amine. And what do we react in the presence of base? and that is a primary amine. Whoops, extra nitrogen there. Plus an alkyl halide, where X is chlorine, bromine, or iodine. Now, what's our isopropyl? What's our prime isopropyl? So that means one of these is, it doesn't matter what you put first when you're writing answers, this amine. Our prime, the carbon here with the nitrogen, is the carbon here with the halogen. So isopropyl again, and again, this one, and you can pick any one of these three, because I haven't shown you anything here that would help you. And I'll use chlorine this time, because this is easily put bromine or iodine. And that's how you do it. Now remember, non-bonding electrons attack from nitrogen, the halogen carbon with the halogen, kick it out, and form a new carbon-nitrogen bond, which isn't as rare as a carbon-carbon bond. And now let's go to, on this slide, number 3. If you take a secondary amine and react it with an alkyl halide, this non-bonding electrons attack, and you get a tertiary amine. And the company I worked for, we did these reactions. And the question would be, and I'll do one, then I'll let you have fun too. What would be the product or products for the following reaction? If we look at this, what's different? Notice I have a bracket here. That's actually a secondary amine. In this case, R and R prime are the same. And then, excuse me, carbon-carbon halogen, alkyl halide, in the presence of base. Remember, X can be chlorine, bromine, or iodine. And this attacks that, kicks out the halogen, and forms a nitrogen-carbon bond. And notice there's 3 bonds to nitrogen, so I have no hydrogens there. Well, this is my R double prime, and I could write it one way. My 2 R groups, R and R prime, are the same, so I can do it that way. And my final R group is ethyl. Now, I wouldn't, but you could just as easily have written it this way. And on a test, either way would be correct. I'm not going to force you to be a lazy organic chemist. And that's how you react a secondary amine with base and a alkyl halide to make a tertiary amine. And again, on a test, I will never ask what's a primary amine, secondary amine, or tertiary amine, but I do use those terms in our classroom, and that's why I defined them. And I better give you one to try. Ooh, I've got a good one. Your turn. see a couple people done. All right, I think everybody's done. I'll give you, yep, I think everybody's done. So I better get to work. And the question is, what's the product or product for this reaction? Organic, that is. If we look at here, what's different? Well, I have a cyclohexane ring. That's just carbon hydrogens and a methyl group. Ooh, nitrogen. This is a secondary amine. And what's different? Carbon, oh, halogen, alkyl halide. X can be chlorine, bromine, or iodine. And now, in the presence of base, this attacks the carbon with the halogen to form a tertiary amine. So what's R? Doesn't matter which one of these you call R and the other R prime. You could have just easily reversed it. And this is my R double prime. So I have my methyl group on nitrogen, my cyclohexane group, and another methyl group. Now I could have put it in brackets like this. And either one of these is correct. Now, if you've noticed, I've been asking a question that you should really ask, why am I learning this stuff? And the obvious answer is you want to get into a program that said you need this, either get a good grade in organic chemistry, you can't get in our program, or you can't get in our school. And that's why you're taking it. But why take it? Let's take a look at the reaction you just did. Now, later, probably next week, this semester's really accelerating. Like I got my foot down on the gas pedal of a Lamborghini. I wish I had a Lamborghini, but maybe next year. But anyways, when I will be teaching you about urethanes, it's a type of polymer. How many of you are familiar with that when you sit on a couch or you sit in a car seat? It's not like sitting on a piece of wood or metal. It's got something soft and squishy on it. And we call that foam. How do you make that foam? I'll teach you next week, I think. But an important aspect of making that foam, excuse me, is having a catalyst. And a catalyst is something that makes a reaction go faster. And for urethane foams, this is one of the best catalysts. It's got a trade name, Polycat 8. I think Air Products is making it now. One company sold it to someone else, or it's going around. But anyways, it's got 6 plus 2 more 8 carbons, poly meaning polymerization catalyst. And back in, I hate to say this, mid-1980s, I was already using this on a project I was working on for one of my patents. And Polycat 8 is an awesome catalyst. How do you make it? Well, we just did it. And that's how you make tertiary amines. Now, with all of these, there's nucleophilic attack. Nucleo means positive, philic, lover. And the carbon with the halogen is slightly positive. So that's why the nitrogen attacks the alkyl halide. Well, in a tertiary amine, there's still a pair of non-bonding electrons, which leads us to one of the most important reactions in my life because it helped pay for my mortgage, new cars. It got me to Mexico. It got me to Australia, not Australia. It got me to Europe. It got me to Canada. It got me to a lot of places. I was supposed to go to Japan, and then I was really upset because they sent those people to me. I was all ready to party hard in Tokyo. Well, I never got that opportunity. Shucks. But anyways, tertiary amine reacts with an alkyl halide. X here is chlorine, bromine, or iodine. And this makes a quaternary ammonium salt. And a quaternary ammonium salt has that structure. And let's look how you make it. If we look at the following, what would be the product or products of the following? And the answer is, let's find out what's different. Oh, look, don't forget there are 3 methyl groups on that nitrogen. So this is a tertiary amine where all R prime and R double prime are methyls. Ooh, carbon-carbon halogen and alkyl halide. And when you react it, this goes here, kicks this out, but because both electrons are come from the nitrogen in a quaternary ammonium salt, it doesn't matter which side R prime and R triple prime are, you'll have a plus charge here and you'll have the anion. Now, I should point out, this is an ionic bond to the nitrogen, not a covalent bond. So nitrogen still has 4 covalent bonds. That's why it doesn't need a hydrogen. This is a case where, remember I said it could have 3 or 4, here it has 4. So if we look at here, this is my R triple prime. One way of writing this molecule, my 3 R groups are on nitrogen. My new one is this, plus charge. You don't have to show charges, but I will. And what's the halogen? It comes from here, bromine minus, and that's what you get. And that's how you make a quaternary ammonium salt. And it's your turn. Give the organic product or products for the following reaction. 3 points each. I see a couple people done, and I'll be quiet. Excuse me. All All right, I think everybody's done, so I better get to work. Remember, R sub T means tallow. There are two of them and a methyl group on there. So this is a tertiary amine. Ooh, carbon, halogen, alkyl halide. X can be chlorine, bromine, or iodine. In the presence of base, you'll get a quaternary ammonium salt. Where all the R groups could be different or the same or whatever. And this quaternary ammonium salt has an anion. Don't forget that or you'll get it wrong. What's R and R prime? Tallow. What's R double prime? Methyl. What's R triple prime? Methyl. Now, one way you could have drawn this, remember, this attacks and bonds to that. We're going to have one methyl group and we're going to add another. You could have written it this way. If you don't put charges, I won't take off points. And I need a little more room, so I'll do this. And you could have also written it this way. And you could have put it another way where two sides have R sub T, two sides have methyl, and you still have the chloride anion. Now, this reaction is near and dear to my heart. I know this reaction is best as good as anybody, probably better than most people who've ever worked in organic chemistry, because the company I work for, we use this reaction to make millions of pounds of this fabric softener, ditallow dimethyl ammonium chloride. Oh no, I'm out of time. Time flies fast when you're having fun with quaternary ammonium salts. See, Dr. White's having fun. Hopefully you are. Thank you for putting up with me and under my stressful day, which after in a little while, I'm going to email you your password for test 2. And you have till tomorrow, 11 a.m. to get it up to me as a single PDF file. And I promise by Sunday, 1 p.m., I will have the grades in D2L. Probably I'm shooting for Saturday. Tomorrow I've got a busy day. I get to get new hearing aids. Yay. Wait until you have to do that. It is good when the old ones aren't working well, because I have amplified speakers. I don't need them right now. But anyways, don't forget to do test number 2. Don't forget next Monday, the lab we did yesterday is due. And with that, I'm going to say, gehen gesund. Goodbye. Have a nice rest of the weekend. Also, by Sunday afternoon, I will email out the individual points for each answer on test 2 to you also. And next Monday, I will go through test number 2 answers, but I will cut it out of the video. And with that, gehen gesund. Good luck on test 2. Hopefully you won't need luck. Bye now.